Okay, so the recording has been started. This indicate the recording. Okay.
Okay, ma'am.
Is my screen visible? Hello?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am. Yes.
Yes. So this is your course portal.
Oh, live session.
Say orientations, playlists, and live session resources. In the week 0, the links were given, no? So here, this is a course playlist where your professor, somebody has on the mic, please switch off. All of you switch off your mics. Yeah. See here in the week 0, in the week 0, you are given important instructions and links. Under that, you have orientations, playlists, and live session resources. Okay. So the course playlists are nothing but the recorded sessions of your professor you'll have in your course. Okay. This already it will be provided here. In each week, that week videos are provided here. Okay. So that link is the course playlist. Whereas overview of the course structure, this is the introduction video. Okay. Live session links. See here, live session links.
Okay, ma'am.
Wait. Here, live session links is there, no? Here, after completion, we will paste the live session link. Live session link here, it will be pasted. So you can go to that, through that link, you can access the YouTube channel. Okay. After
Okay, ma'am.
completion of the live session, we will post it here. And even
Okay.
you can search for your course live session in the YouTube, you will find out. Okay, you can subscribe to that so that you can directly view the all the live sessions
Okay, ma'am. Thank you, ma'am.
from there. So let me first give a brief introduction about week 1 content, and then we will start. So every week I will answer this one. Practice assign. So for the first 2 weeks, you won't have the programming. Programming practice assessment will not be there for first 2 weeks. Whereas from 3rd week onwards, you will have a programming practice assessment. Okay. So for the first 2 weeks, I will discuss the theoretical practice assessment only. Theoretical practice assessment only I will deal. the first 2 weeks. Okay, so before answering this, let me give a brief introduction about week 1 content, and then we will come to here so that we can answer the questions easily. Okay, all of you switch off your mics. Okay. Switch off your mics, only you on whenever you want to have a doubt. Okay, because noise is coming, that's why I'm saying. So what is a computer? So computer is an electronic device which is used to process the data and perform the calculations and execute the instructions. So like that, you can use it. Is an electronic device. It will be able to process the data by the user, and even it can show you the solutions for some of the tasks given to it. So the computer will mainly have 3 parts: central processing unit, memory unit, and it will be having a storage devices. So the central processing unit is called the brain of the computer, which is responsible for executing all the instructions given to it. Okay, and your central processing unit will have units like control unit and arithmetic logic unit. So control unit it will manage all the instruction, all the operations that need to be performed by controlling all your input and output devices. And arithmetic logic unit is the one which will perform the operations, arithmetic, logical and arithmetic operations. Wait, somebody's mic is on, that is disturbing. Mathayarian, please switch off your mic.
Okay, ma'am.
Yes. So CPU will have 2 parts mainly, the central processing unit and arithmetic logic unit. Arithmetic logic unit will perform the logical and arithmetic operations, whereas central control unit will control all your input output devices. So memory, in the memory you will have 2 types, RAM and ROM. So this RAM is called random access memory. Generally when we use this random access memory is, so when you want to execute your program, so first the program will be loaded into the main memory, then only it can able to execute that program. So that main memory is nothing but the RAM. So first program is to be loaded into the RAM, then only it can able to execute each instruction one after another. Okay, so because the data can be read from the read or write to the memory RAM quickly. Okay, so ROM is nothing but your secondary storage device like hard disk. Okay, that we call it as a ROM, whereas main memory in your system, in your computer, is called a RAM. Okay, so whatever the data that you are storing in RAM, random access memory, that memory is called a volatile memory. What is mean by volatile is, the data in that memory will be lost when your computer is power off. Okay, so now if you are working, so you have executed one particular program, so that code, whatever the program code, that it will be loaded into the RAM. So once you terminate your program or switch off your computer, the code which is there in the RAM will automatically erased. That's why it is called volatile memory. When the power is off, it will automatically erased. So to execute next time, again you need to load that into the main memory. Okay. So you'll have storage devices, your hard disks, hard drives, some external storage like pen drives. Okay. So all your SSDs, all those are called as storage devices. Okay. All the storage devices are non-volatile memory devices. Non-volatile. That means the data stored on those devices will be stored permanently, even when the computer is turned off. So the data will retain. It will retain the previous data. Okay. So that all your storage devices are non-volatile. Your hard disk, your pen drives, all those are non-volatile. And input devices, generally how your computer will work, it will have mainly, it will take the data from the input devices, and that data will be processed by your CPU, and that processed output, it will send it to your output devices. Okay. That processed data, it will send it to the output devices. So input devices allow the user to enter the data, whatever the input data that is required by your for processing, that will be provided through input devices. So the most frequently used input devices are the keyboard, mouse, touch screen, and microphones. All these are some of the input devices. Okay. Whereas output devices will help you to display your result on the to the user. To display your result or present your result to the user, we use output devices. So the best example of output device is your monitor. Okay, where you are seeing your output result. So the examples of output devices are monitors, printers, speakers, headphones. So through which you are getting you are able to see the data or hear the data. Okay. Or you need to print the hard copy of that data, so that you can do it using output devices. So inside your CPU, you will have a motherboard. It will connect the different components, like all your input devices, output devices, CPU, all those will be connected by your motherboard through some communication channel. So it will provide like using wires and all. So it will able to transmit the data from input devices to the CPU, and once it calculates the result, that result it will carry to the output device. So it will provide the communication, motherboard will provide the communication facility between all components of your computer. A software is a program or the instructions given to the computer to perform a particular task. Say, suppose I want to say add any two numbers. Okay. So to say that add these two values, so I need to give one instruction. Okay. So because the computer cannot understand our language, either English or Telugu or whatever it may be, that language cannot be understood by your computer. So computer can understand only the binary language. You whatever you are saying, it should be said in the form of binary digits, binary value, like zeros and ones. Only that language it can able to understand. So whatever code that we are writing, so it will be converted into the machine readable form by your softwares like compiler, interpreter. There are so many softwares will be there. So those will translate what the high level language that we are speaking or we are giving the command, that is translated into the binary language which can be understood by your machine. Okay. So how your computer works is, it will take the data from your input device, okay, and that data will be transmitted to the CPU for processing, and that processed data, while processing the data, it will take the data from, it will pass the data through and flow to the memory, and for processing, it will make use of arithmetic logic unit for calculations. While processing the data, there might be some calculations. So for doing the calculations, it will take it from it will take the help of arithmetic logic unit, and for performing the data operations, it requires some input data from the input devices, and that data after result it need to pass to the output devices, that controlling all your input output devices, and passing the instructions from one memory from memory to the registers, and registers to the memory, that everything will be controlled by your control unit. Okay, so so we'll see the detailed functionality of each one. If you have any doubt, or if any disturbance in my voice or a display, okay, you respond, ma. You respond. Okay. See how the computer will perform operations. I'll give a brief one example. Say, for example, you want to say add 3, 4. You want to add, say, C is equal to A plus B. You want to perform this instruction. C is equal to A plus B, and the A value is, say, 4. B value is, say, 5. B value is equal to 5. A value is equal to 4. And you want to execute the instruction, this C. You want to calculate the C value by adding those two. Okay. So how this instruction will be executed by your computer is, first it will read. So here A, B, C, we call them as variables. So first, so to perform this particular operation, it needs the value of A, variable. So variable is nothing but a name of the memory location where your data is stored. A, like variable, A is one variable. So variable means it is nothing but the name of the memory location where your data is stored. Everything, whatever that you are processing in the computer, that data, it will be stored in the memory. It will be stored in the memory in the form of bytes. So this A value is stored in one of the memory locations. Say, for example, memory locations are identified using an address. Memory locations are identified using an address. Think that 2000 is a address of the memory location where I have the A value. Where I have the A value. Say, for example, 3000 is the location where I have the V value. Say, for example. So I have the V value. So if you say A is equal to 4, so what it will do is, to process this data, if it needs to perform this operation, the computer can able to perform that operation only when the data is in one of its internal registers of that processor. So your CPU will process the data, I told you. So inside the CPU, you will have so many registers. So registers are also something like memory locations only. They can also carry some data. They will also be able to store the data. So your computer can able to do the operation only if the data is in one of its internal registers. Okay, so that means if it wants to perform this operation add, so this data should be found in register, not in the memory. So now our data is in memory location. So to perform this operation, it needs to bring that data to the one of the internal registers. So what it will do is, first it will load. So load R1, comma A. So that means A is a memory location. From this particular memory location, it will bring the data, it will fetch the data, and that it will store it in R1. So the load instruction, what it is saying, it will fetch the data from the memory location, and that fetched value, it will store it in this register. So from which memory location it needs to fetch the data, that we are saying here. That is nothing but a 2000 location. Okay, so from an address of 2000 location, you fetch that data. That data, it will store it in R1. So that is the load instruction. First, it will load the data into the registers. Same way, again, R2 will be loaded with second register. Say R2 is loaded with the value of B. So B is at, we thought that our assumption that the B is at 3000 location. So from that location, it will fetch the data and store it in R2. Am I audible, ma? Am I? Hello? Hello?
Yes, ma'am.
Yeah.
Yes, ma'am, you're audible.
Yes, ma'am.
Yeah. Okay. So load your data. A value you are loaded into R1, B value you have loaded into R2. So now the data is in the internal registers of the processor. Then it can able to perform the operation now. So what operation it need to perform? Add operation. Add, it will say R1, comma R2. It will say add R1, comma, like this, these instructions, they add, load, these instructions will vary based on your processor. If it is an 8086, you might have a different instructions to perform the task. If it is 8088, you may be having a different instruction. So instruction set will vary from processor to processor, but the operation will be done similarly only. Okay, so it will add the contents of these two registers. So after this instruction, what is the value of R1? What is the value of R1? What is the value of R1? 4. Because in this memory location, which value we have? 4. That value, it will store it in R1. So now after this instruction, your R2 contains 5. Okay. Now add R1, R2 means what it will do here is, so it will add the contents of R1 and R2. So 4, see here, again that result, it will be stored in R1. It will add the contents of these two, and that result again, it will be stored in R1. So, okay. So R1 will have R1 plus R2. So that means after the execution, your R1 value will be, your R1 value will be 9. R1 value will be 9. R2 doesn't changes. R2 will be 5 only. R2 will be 5 only, whereas R1 will be contain the addition of those two because of distance. So it will be add these two values, and again that result it will store it in this. Generally we call this as source and destination. So these two will be added, and in the first register it will store the data. Now what we want the result in a memory location where C, variable C is pointing. So let us think that this is, we thought that this is the memory of A, memory location of A. This is the memory location of A, and this is the memory location of B. And let us take C, the memory location of C is say 4000. Okay. So now, where is our result now? Our result is in R1, and where we want our result, it should be stored in C. So the C is pointing to this particular memory location. So for that, what we need to do is we need to store instruction. So what it will do is it will store the value. It will store the value of a register into the memory location. So the R1 value will be stored to, this is the memory location. The memory location 4000 memory address location, it will store the value of R1. So internally we are giving only one instruction, that is C is equal to A plus B. But internally inside the CPU, what happens? It is executing almost 4 instructions, 4 or 5. It might be depending on the instruction that we are giving. So first it is loading the R1 A value into R1, B value into R2. After that it is performing the operation, and that result again it is storing into C. Internally it will execute like this. Okay. So to read from memory devices, the value that is, we need to place this particular address on the address bus. So that instruction, that signal will be given by your control unit. So you read the data from this location on this bus and then store it in R1. So while performing the operation, we need to communicate between your memory and to your input devices and to your output devices and your processor. Okay. You need to communicate between so many components in your system. So that work, it will be done by your control unit. So the control unit coordinates and manages the execution of instructions. It will fetch instructions from memory, decodes them. Decoding means it will convert into understandable form by your machine. Okay, decodes them and directs the CPU accordingly. So what operation? Here we are specifying what we need to. So the load L instruction or load instruction will help you to fetch the to say that the meaning of that is you fetch from memory and store it in register. Whereas store instruction, it will instruct the CPU that whatever the value that you have in this register, you store that value into the memory. So add means it will instruct the CPU to add the contents of these two. So like that, which operation you are going to perform, so that will be directed to the CPU based on this decoded value of that instruction. So it controls the data flow between the CPU and memory. So that is the task of your control unit. Okay. So it will fetch the instructions from the memory, decode them, and instruct the CPU according to the decoding. And then the data flow. fetching the data from memory to the register and register to the memory. So that flow will be taken care by your control unit. Okay, so where you'll have your data. So when we are executing your program, your data will be on RAM. First, it will be loaded into the RAM, main memory. So this is a temporary storage. It will contain the data till you terminate your program execution. Okay, so this is used by the active processes which are running in your system, RAM. Whereas a ROM is a permanent storage, your secondary storage devices like your hard disk and all. Okay, this is essential to store your programs. Say in your after writing the program, we will save it. So where it will store, it will be stored in ROM. When you execute it, it will be moved from ROM to the RAM. Okay. So the arithmetic logic unit, it will perform like I said, add these two values. So that addition, subtraction, multiplication, division, whatever operation we are specifying, even the logical operations like and or not, these will be done by your arithmetic logic unit. Output stage. So the result, after getting the result, the user can view that result when it is displayed on your output device. Okay, so the famous output device that processed data is sent to output devices for user consumption. So the output devices are nothing but monitors, printers, speakers, and your display devices, whatever may be that display devices, all are output devices. Okay. Communication, generally it will be done through the networking or the cables, whatever it may be. Okay. And how the program will be executed is, see here I have written 4 instructions here to perform this. So it will do the instructions one after another. First it will do the first instruction. After that it will execute. So instructions are executed in an order, one after another. Okay. So while executing the instruction, it will fetch the necessary data and decode the instruction and execute that instruction, and that output data, it will send it to the output device. Result, it will send it to the output. Okay. So the computer can only understand the binary language, binary code, that is in the form of ones and zeros. So this decoding is nothing but it will convert. But if you suppose whatever the operations that we are doing, every operation is given one number in the form of ones and zeros. Is it possible for us to remember all those? Impossible, because add will have some value, to subtract, like that we will perform thousands of operations. So remembering the binary code in the form of ones and zeros for all those thousands of operations, it will be very difficult for the human. So that's why we always give the instructions in our comfortable language, that we call it as a high level language, and that high level language is converted to the machine understandable form, to the binary language, by your compilers and interpreters. Okay, so that is the brief introduction about your components and all. Already we have seen here. So in the memory, you'll have, this is the hierarchy of the memory. CPU registers will be in the nearer to your CPU. So generally your CPU will fetch the data from these registers only. It will work with the data while executing your instructions. It will take the data from the registers. So if you have the data in the registers, they will be accessed fast. Okay, with the high speed, it can able to access the data inside the register. Suppose if your data is in your hard disk, so first it need to fetch that, bring it to the main memory. From the main memory, it need to bring it to the registers. Okay, it will take time. Suppose if the data to be processed is in the register, it can able to do that operation fastly. Okay, so as we come from registers to the magnetic tape, the speed will decrease. Okay, the speed will decrease. So whereas capacity will be increased. Like here you will have only limited number of registers. In the CPU you will have only limited number of registers. So you can't store much data. Only the instruction, current instruction that is being executed, the data is only stored in registers. Whereas the other data you cannot store. So very, very less number of registers will be there based on the processor. Okay, so next high speed memory is the cache memory. So in the cache memory, we store the instructions that we access frequently. Say suppose I am performing a particular task. So in that I am performing the add operation 9 times. So in that case, the data required for performing that add operation, so that it will be in the cache memory. So frequently accessed data will be there in the cache memory, so that your processor can access the data somewhat faster. Cache memory is also more speed. It will work. The accessing time of your cache memory is also very less. Okay, it can access the data somewhat faster. Whereas next high speed is main memory. Next, all these are the secondary storage devices or your hard disks. Okay, so this is the memory hierarchy. So the when your hard disk, you can have a more memory in the hard disk. But whereas when you come to the registers, where there are very few registers, so they can contain only a small memory. Okay, so the memory capacity will increase when you come from registers to the secondary storage devices, whereas the accessing time will be access time of the registers is faster, whereas hard disks is slow. So why we need to write a program is to perform a specific task. Okay, suppose you want to calculate something. Suppose you have a student data along with their marks in one particular Excel sheet. Okay, student roll number, name, and marks in 5 subjects. Now I want to know who got the highest marks. So what I need to do, I need to calculate the total of all the subjects, total marks of all the subjects, and then I need to give the grading. And so I need to that task, doing that, calculating the total value and finding the average marks. So that is nothing but processing the data. Okay, so for performing that processing, we need to write a program step by step. So step by step, how you perform that, for that we will write the code. So programming, we write it to perform a particular task. So there are so many programming languages to communicate with the computer. Like as a users, we want to communicate with the computer and say you perform this particular task. But we know the high level language, whereas the computer will know only binary language. Okay, so we need to communicate, we need to give the instructions to the computer by using some particular syntax. Okay, so there are so many languages that will help you to communicate with your computer. So they say two persons can communicate using either a Tamil language or English language or Telugu language. Like that, there are so many languages for communication. In the same way, to communicate with your computer, we have also so many programming languages to give the instructions to the computer. So those are like C, Python, Java, C++, JavaScript. All these are the different programming languages. You have so many. Okay. So algorithm means step-by-step instruction given to the computer to solve a specific task, specific problem. Okay, that we call it as an algorithm. Say for example, suppose we want to make a coffee. So what are the steps that we need to follow to make the coffee? So first we need to heat the, so we need to specify that step by step. First step is heat the water, boil the water, and then add coffee powder, and then filter it, add the sugar, add the milk, again mix all of them and boil, so that it will prepare a coffee. So those are how we are doing that task. So if you explain that step by step, that we call it as an algorithm. So algorithm doesn't depend on any programming language. It is not specific to any programming language. Just it is a general step by step process to solve the task. So generally, suppose you want to prepare one particular application or a software. So what are the different steps that we will have is, first we need to design a particular application. First we need to understand for what purpose you are designing the solution. So you need to understand the problem definition. Okay, so after understanding, you will design the solution. You will find out you will write the code to solve that problem. So after that, we need to test it, whether the code which was written by us, is it working correctly or not. So we will give some input, simple input, and whether we will check whether it is resulting our expected output or not. Okay, so that is called testing. So while testing, you might find some errors. Maybe you are expecting your result in some way, but it is giving a different result. In that case, what we need to do, we need to find out where you have the bug or the where you have gone wrong. So again, re-modify that code. Again, we test it. So till we get a successful results, so we will test it. Once we find that we are getting the correct result, then we give this code to the customer, where to the real time, where the customer is working with that application. Okay, so that we will document that code and then give it to the customer. So customer will be working on it, test in a real time. So if any bug comes, again we need to take it for the maintenance. Say some specific period, we need to maintain that. Maintenance phase is to be done in the software development life cycle. So these steps will be repeated till we find that your application is working fine. So sometimes what we need to, after giving to the customer, it may cause some problem. So again, after the customer notifies that, again we will check, all these phases will be repeated. Whether we understand the problem correctly or not, we will analyze it again, recode that, and again retest it, and then again send it to the. So optimization is nothing but, like, suppose to solve a particular problem, we might write n number of solutions. Not a single solution will solve the problem. We might write n number of solutions. So the best solution is nothing but the solution which takes less time to execute, less memory to store. That will be the best optimized solution. Okay. So once we find the solution, we try to optimize it. And like the features available in the, with the features available in the language, we try to simplify the steps that you have written, so that steps will lead you to the solution. So that is called optimization. So the best code will be the code which takes less time to execute and occupies less memory, will be the best code. So there are different types of programmings, like application programming. So generally we use this application programming for designing applications like see your word processor, Word document. Generally we use that document for typing your letters. Okay. Like lecture notes, prepare the lecture notes, like for all the purposes we use word processors. And games, nowadays there were so many games in your online. So for preparing such a games and mobile apps, for all those purposes, we the software which we use is called application programming. Okay. Whereas websites, so you are for online sales, nowadays many of them are using websites. So for e-commerce applications, everything, generally we use a web development, web application. So web applications are designed using the languages called HTML, CSS, cascading style sheets, JavaScript. All these languages are used to design your web pages. Whereas embedded programming, that is the code run in your smartphones, or like suppose your washing machine. So it will automatically working on different modes. So inside that there will be one processor. So that processor will have some embedded code with it. So when you switch on that option, so it will work according to the code that was there inside that. So your smartphones, IoT devices, like all those will work with the predefined code that will be there inside it. That we call it as embedded programming. Okay. And even you can analyze the data, present your data in the form of graphs for easy understanding. Okay. So that we call it as data analytics programming. Okay. Like that you can do different types of programmings, application programs, web designing programs, embedded programming, data analytics programming, like that. So for writing the program, we need an editor. We need an environment where we can write a program. Okay. So those environments are called text editors. Something like here, to explain you something, I have used a Notepad. So Notepad is one of the text editor. Your WordPad, Notepad, Notepad Plus. So like all those are the Word some of the text editors. Whereas IDEs means the IDE will contain an environment where you can type your program. Editors means only you can able to type the program. You cannot store it or compile and execute it. Whereas IDEs will be an integrated development environment where you can type your data, or type your programs, as well as you can compile them and execute them. Okay, so everything will be bundled. Editors. So for editing the data, for typing the data, we use editors. For compiling, like checking the errors and linking all the different modules, and also we may use debuggers. Okay, so debuggers. So like to convert from high-level language to the machine language, we need translators. So like compilers. So all those tools, compilers, interpreters, editors, the combination of all those will be included in the IDEs, integrated environments. And nowadays, you also have a version control systems like your GitHub to share the data between multiple users. Suppose if multiple users are working on the same project, but from a different geographic locations. So to share the data between them and collaborate, the code written by all the users can easily be managed using GitHub. That we call it as a version control system. Okay, so till now we have discussed the basics about the components of computer and their functionality. So first we will try to solve the problem, the questions in these concepts first, and then again we'll come back to the introduction to the C programming. So let me solve the questions now. Try to answer, all the questions will be in the concepts that we have discussed now. Try to be interactive while solving this. Which of the following statements best describes programming? So what is mean by programming? Respond, ma.
Set of instructions.
Set of instructions given to the computer to perform a particular task. Okay, so which option is giving that meaning? You see it. It refers to how the data is organized and stored in the computer memory. No, programming it is not storing or retrieving. So it refers to the process of instructing the computer to perform a given task. Okay, so this is correct. It is programming is the process of instructing the computer to perform the given task. It refers to the hardware. No, it is not referred to the hardware. So the correct option is the second one. It refers to the process of instructing the computer to perform a given task. So that is programming. Which of the following is or not a valid logical operators in programming? So already we have seen what are the logical arithmetic logic unit. What it will do is it will perform the logical and arithmetic operations, we said. So there we have a list out of what are the logical operators. So the logical operators are and, are, not, and, are, not. So which among these? So, and is a logical operator, not is a logical operator, but assignment is not a logical operator. COs are not logical operators. Okay, so you have a questions like this: MCQ, multiple choice questions, or MSQ, multi-select questions. multiple select like if you are given this square box, that means that more than one answer is correct. Whereas if you give this radio button, that means you need to choose any one of these options. Okay. Next, which of the following statements is generally true? The memory unit is responsible for performing arithmetic operations. Is it correct? Which will perform
No.
the arithmetic
No,
operation?
ma'am, not at all.
ALU will perform.
Okay. So this is a wrong option. So not correct option. Next up. Registers are responsible for performing arithmetic operations. This is also wrong. ALU is responsible for performing arithmetic. So this option is true.
True.
Okay. All is anyhow wrong because these two are wrong. All will not be wrong. Next, which of the following statements is or true for a split memory architecture? So split memory architecture means it will work like this. This is called a split memory architecture. So it will fetch the data from the memory and store it into the internal registers and then perform the operation on internal registers. Again, that store back that result to the memory. That if it perform the operation in that form, that is called a split memory architecture. Okay. So in the split memory architecture, which of the following are true? ALU fetches or writes the data directly to and from the main memory. Is it performing the operation? ALU directly, is it taking the data from the main memory? No.
No, ma'am.
Where it is taking the data from registers to perform the arithmetic operation. So this option is wrong. It is not true. So input data is fetched from the main memory and is temporarily stored in the registers to perform the computations. So this is correct.
True.
So we are fetching the data from the main memory and that we are storing in the registers for performing the operation, computation. So again, the result of the computation is again stored in registers that we will return back to the main memory. So this is also true in the
True.
split memory architecture. So only these two are true. Next question, which of the following statements is true or correct? Okay. So what is mean here? Is giving the instructions about load and store. Load means what it is doing. Load means what it is doing. It is fetching from the memory, storing into register. That is called load. So load refers to the process of moving the data of main
From
memory
to registers.
So this is correct. So it is moving the data from main memory to the register. So load refers to the process of moving data from register to main memory. This is wrong. Okay.
Wrong.
Whereas a store refers to the process of moving the data from register to the main memory. So this
Main
last
memory.
option is correct. Okay. Load means it will move the data from main memory to the register. Store means from register to the main memory.
Main memory. Yes.
Yeah. A typical CPU keeps track of the position of the next instruction being okay. See here. Suppose we write some set of instructions here. Say for example, add something and then load something, store something like that. We have written some instructions one after another, say for example. So how it will perform is, first it will take the first instruction, then the data needed to perform this first instruction is fetched and then perform the operation, store the result. After that, again it will take the load instruction. So what happens when it is processing the operation, when it is performing this particular operation, it needs to process so much of data. That means it need to move from one place to another, something like from ALU, it need to move to the main memory. From main memory, it need to go to the fetch the data from input device. So like that, it needs to transfer. The control is to be transferred from one location to the another location also. Say previously also, A data is in 2000 location, B data is in 3000 location. So that means it needs to move from, to fetch the data, it needs to move one memory to the location to the another memory location. Okay, so while moving this, again after performing all the operations on these memory location, it again come back to the next instruction. Okay, after completion of this instruction, again it need to come back to the next instruction. So how it will be able to know what is the next instruction, and that I need to perform is, so before it move, it will start after reading the first instruction, the next instruction is to be performed is loaded into your program counter. The address of the next instruction that you need to execute will be loaded into one register called, that we call it as a program counter. Program counter will contain the next instruction, address of the next instruction to be processed. So a typical CPU keep tracks the position of the next instruction using dash, program counter. Okay. Which of the following is true for C programming language? Okay. So let me discuss. So next, let me discuss some C programming concepts, and then we again will come back to this place. Okay. I'll give a brief introduction about C programming. So these are the key characteristics of C programming. It is a procedural language. So to perform each and everything, we call a function. A function or procedure is nothing but a subprogram which will perform a specific task. Okay. Generally, how it will follow the modular architecture. That means, say, suppose you need to solve some complex problem. We need to solve some complex problem that is divided into sub-problems. That is divided into sub-problems. And each sub-problem is solved
by function.
The sub is nothing but a function. We will write so many functions. This is the main. We call this as a main function. From them to perform that particular task, we divide the task into different functionalities, and we will solve. We will give the solution to this sub-problem, and again we will give the solution to this sub-problem. Again we will give the solution to this sub-problem. All these solutions are combined to get the solution to your original problem. So that we call it as a modularity, dividing the complex problem into smaller sub-problems, and combine at the end, we will combine the solution to all the sub-problems to get the solution to the original problem. Okay, that we call it as a modularity. So it will follow the modular approach. The C programming language is a structured programming language. That means it will provide all the control structures, like to repeat some instructions, it will provide the loops. To check whether this is true or false, it will check, it will provide the control statements like if. Okay. So like for each and every operation that it needs to do, it will provide a proper structure. a group of values of same type. To store that, it will use array. To group similar data items into one unit, it will use a structure. So like that, it will provide all the necessary data structures that are required to perform the tasks. Okay. Portability is nothing but, what is mean by portability is nothing but when you write a code to run your program on Windows, say for example, you have written a code in your computer, the Windows operating system is there. So you written the code to run in your Windows operating system. Suppose later some other friend asked your code, so you have provided the code. So his system is a Linux. He is using a Linux operating system. So if the same code which is provided by you is able to run by that your friend without any modification, that means that is called the portability. So it will support the portability. So all your C programs, when you change your platform or when you change your environment, you need not modify anything, or you need to modify a little bit. Okay, minor modifications are required to run that in a different environment. So that we call it as a portability. Efficiency means it can like fast. The C programming language is nearer to your machine language. All your compilers, interpreters, they are written in using a C language only. Okay, so it will be nearer to the binary language. So when compared with other programming languages, the code which you written in your C language will be worked faster. It will do fast access the data, or like it can able to access your hardware devices somewhat faster compared to other programming languages. Like to run your program, you need to fetch the data from your keyboard, like input devices, and store the data to your output. So the communication it can able to do faster using C programming language compared to other. So it is called a strongly typed, can't say it strongly typed, but it will provide a sufficient data types to process all categories of data: numerical data, text data, string data. So all types of data you can able to Boolean data, everything you can process using the data types that are provided by your C language. And it is also having a standard rich library. That means, so library means, say for example, you are performing some mathematical operations. So general mathematical functions you require is a square root. You need to find out the square root of a given number, or a power of a number, or like that sine value, cosine value. So like that, you need to find out some arithmetic operations. So to perform all those arithmetic operations, we have the libraries. One function will be provided, so that it will, how it will do, you need not know. Just you need to give the input to that, so it will give you the output. Say suppose if I say SQRT of 9, so it will give you the square root of 9. Okay, so like that, you will be provided with the rich libraries for performing all types of operations: string operations, mathematical operations, okay, input output operations, okay, memory management operations, everything. To perform all types of operations, you will be provided with the library functions. Okay, so these are the main characteristics of a C programming language. So it is procedure oriented language, provide the portability, and efficiently without errors it will execute, and faster. So it will provide the data types to support all, to process all categories of data. So, and it is also having a rich library to perform specific task. It will provide the functions. So the basic thing is, so before learning any programming language, so not you think of learning you are learning English, say for example. So newly you are learning a particular language. So first, what we will learn when you are like forgot about computer languages. So in general, I am asking, suppose you want to learn a new language. First, what you learn about that language?
Like ma'am, if you want to learn English, so we need to learn first alphabets.
Alphabets. So here, alphabets are nothing but in the computer. When you are speaking in terms of computer language, we call this alphabets as a character set. Learning
Character
the
set.
alphabets is called a character set. Every language will support a particular character set. So whatever you are writing, the instruction that is written in that language will be formed using only these characters. So that we call it as a character set. So first, you need to know what is the character set supported by the language. So once we learn the alphabets, so what will will learn? We will form the words. Okay, after learning the alphabets, what we'll do? We will form the words. Using those
Word.
alphabets, we will form the words. See here,
And then
when you are
able to
talking,
write a sentence.
yeah. Uh, so words. So in the computer sense, we call that as tokens. So using a character set, it will form tokens. So tokens are nothing but we can say it as a constants, variables, operators. Okay, all those are called tokens. So um, once we form the, so tokens means what will comes under token? Variable is nothing but the memory location, address, name of the memory location where you store the data. That is called variable. Constant means whose value you cannot, first time you can assign the value. Once we assign the value, its value cannot be changed. That we call it as a constant. Okay, operator, data types, operators, all those comes under tokens.
Token.
Okay, so like that you'll have so many. So all these are called tokens. So once we form the tokens, so once we form the words, we will write a sentence.
Sentence.
Okay, so we will write a sentence. So the sentence is nothing but a statement in the computer programming. We will write the statement. So first we will learn what is the character set supported by the language. So using that character set, we will form the tokens. So using tokens, we will form the statements. Some set of statements. So here we'll have a statements also. We'll have a different types of statements. Simple statements, compound statements, control statements. Generally, we'll have a 3 types of statements in C language. Okay.
And so these variables, constants, data types, these collectively are called as tokens, or we need to make tokens using them?
No, variable is one of the token. Constant is
Okay.
another token. Data type is another token. Operators are another type of token. All these are like you can combine them different operators you can combine. Or even you can, while writing a statement, you can combine all those. Say, for example, if I say B is equal to A plus 5, okay, where A, B are the variables, 5 is a constant, and plus is an operator. Okay, so this is called one statement. This is called one statement. This statement is formed using variable, constant, operator. So plus is an operator, 5 is a constant, A and B are the variables, and equal to is also an operator. So like that. Okay. So we will have a different types of statements. So if you combine variables, all the tokens, and form a statement like this, this is called a simple state followed by semicolon. So if you write, if you combine all your tokens followed by a semicolon, a statement followed by semicolon, this is called a simple statement. This is called a simple statement. And this way, what we say it as, this is called an expression. An expression followed by a semicolon is called a simple statement. Okay. Yes. So set of simple statements which are enclosed in open and closed parenthesis is called a compound statement. Say, for example, here I have written like this. A is equal to 4 is one statement, one expression followed by. So this is one simple statement. This is another simple statement. So like that, multiple simple statements which are enclosed between open and closed curly brace. This is called a compound statement. This is called compound statement. If the compound statement, whether to execute this particular compound statement or not, if we decide using one of the controls, like if here I am writing, if some x equal to x, if x greater than 10, you do this. If I say if x greater than 10, then only you execute this compound statement. So that means I am controlling this compound statement based on the variable x. So if x value is greater than 10, then only you are doing this. Otherwise, you are not doing this. So this is compound state. Execution of this compound statement is controlled by this if. This if statement is called a control statement. Okay. So like that, we'll learn all those things in the further weeks. Okay. So from character set, you can form tokens. From tokens, you can form statements. Using tokens, you can form statements. So after forming the sentence, what we do? We will prepare a document. We can prepare a paragraphs or a document. Okay. So we can write a document. So here writing a document is nothing but a program. Set of instructions, set of statements is nothing but a program. Okay, a statement means it will contain an instruction. So the set of instructions or the set of statements is will form a program.
Okay. Ma'am, what is the control statement? Can you explain once?
Control statement means either a simple statement or a compound statement which is controlled by control structure. That means whether to execute that statement or not. Suppose if I write it like this, if A greater than B, A greater than B. Here I have written display A. Else, sorry. If A greater than B, display A. Else means if A not greater than B, then you display B. Suppose I've written like this. That means whether to display the A value or B value, it will be decided based on this statement, if statement.
State called as control statement.
Yeah, this if is called the control statement. It is controlling the whether to execute this simple statement. This is one
A
of the
or
simple
B.
statement. This is one simple statement. So whether this is simple statement or the compound statement is to be executed or not, it is deciding. So that is called control statement. Which
Okay.
there are so many control statement. I have given only a simple example of if. If is one of the control statement. Okay, so we learn the character set. When you combine some set of characters, you can form tokens. So when you combine different types of tokens, you can form a statement. So a set of statement will form a program. Okay, so there we are. So while writing the program, you will encounter all these things. Yes.
Ma'am, I have a doubt.
Yeah.
The examples for tokens, we have constant variables, data types, etc.
Mm.
Is there any example for character set?
Character set means your alphabets, letters A to Z.
Oh, for English learning, we are using alphabets.
Yeah, A to
For
Z.
computer side,
Even
programming
computer also. How you are forming this statement, ma? If is a alphabet only.
Okay.
Okay. Small
Okay.
A to Z. Digits 0 to 9. And you're using a semicolon. Special characters. All these are. Okay. Like that. Even greater than symbol, less than symbol. So like that. Okay. So all these are the different character set. Okay.
Okay, ma'am. Thank you.
Even under this, you'll get keywords also. Keywords. Keywords are the words which are having special meaning in the language. Something like if this is having some meaning. It is checking this. So that there are some words in the language which have a special meaning. Those words are called keywords. So if is one of the keyword. Else is one of the keyword. So these keywords will have a special meaning in the language. So that those will also come under tokens only. Okay. So while writing the program, you will encounter all these variable control structures means if, loops, for, while, all these are control statements. Data types like to represent your data, you may use your data can be an integer or a real number. To represent real number, we use float. To represent the string data, we use characters. Okay. Operators like performing the arithmetic operations, we use all these operators. So we will encounter all these while learning the language. Okay, what are the different data types we have? What are the different operators we have? What are the different control structures we have? Okay, so how to define a variable, how to access the variable, how to define a function, how to access the function. All these things we will encounter while learning the language. Okay. A simple C program is written here. So I'll, whether you understand or not, just listen to it. You will get the clarity when you come to the third week. Third week, you will know what is the meaning of this. Okay, just now I'll explain. So whether you understand or not, you just listen to it. So to write any C program, not only C program, any programming language. Okay. So any program, the basic thing that we need to follow is every program will have an input, that we need to read it from the keyboard. That input we need to give to the CPU for processing input. So the input, first we need to read the input and then process that input to get the output and display that output on the output device. So this is the what we say mantra that we follow to write any program. So we need to read every program. First step that we need to do is we need to read the input. After the next steps, in the next steps, we need to process this input to get the output. And that output we need to display on the output device. While writing any program, you need to follow this order only. How big program it is. So you need to follow this order only. Okay. Say for example, I want to calculate the area of a rectangle. I want to calculate area of a rectangle. What is the formula?
L into B.
So L into B. So here I am using to represent area, I am using a variable A, let variable A represents area, let L represents length, let B represent breadth. So this A, L, B, we call them as variables. Okay. So they represent the data, whatever they. So what I need to do, so my task is I need to find out the area of a room. My task is I need to find the area of a room. That means what is the output in this?
Area.
Area of the room.
Yeah, A. Yeah.
Yeah.
Like among these variables, which is the output variable? A.
A.
To find the area of the room, what I require is nothing but input. So if I know which thing, if I know, I can able to find out the area.
Length and breadth.
If I know the length of that room and breadth of that room, then only I can able to find out the area. So what is required to calculate this output? That is called input. Okay. So first from the keyboard, we need to read the L value and B value. First we need to read the L value and B value. That is nothing but reading the input. Okay. So now we are applying this formula. L into, we need to multiply these two and that result we store it in this variable. That is called processing. Okay. So we are multiplying these two values and that result we are storing in A. So this step is called processing step. Now your CPU has stored your result in this A, where A is a memory location. But you want to see that result. So if you want to see that result, this A value is to be displayed on the monitor. Then only you can able to see that output. Okay.
Yes.
So what to solve? First, you need to understand what you need to do, which problem you need to solve. From that, you need to know what is the input to that problem, what is the formula to find the output from the given input, and how to display that output on the monitor. So that steps you need to know. So whatever data that is required by you to read, that is nothing but reading the input. So to obtain the output from the given input using a formula or some steps, processing steps, that is nothing but a processing. Okay. Processing. And once you got the result, that result, if you display it in your output device, that is called the stuff. So every program will contain input, processing, output. Okay? Every program will contain that. So if you know how to read the data from the keyboard, and your operators or statements will help you to process your data, and you need to know how to display your output on the monitor. So for that, today I'll give you a simple instructions how to read the data and how to display the data. How to read the data, we have a built-in function called scanf. Scanf, it will have the structure, control string, quotations, comma, and symbol. Here we need to provide variable name. So this is the syntax. So which value I need to read, that variable name I need to provide here with the and symbol and variable name. And inside this, we need to specify a control string. This control string will depend on what type of data that you are reading. So here in general, when you compare with the real world, can you tell me what are the values that you can give to the length and breadth? What type of values? Whether integers or whether real numbers, whether string. So like that, what type of data will have for length and breadth?
And decimal to the real one.
Yeah, either it can be an integer value or it can be a real number. Okay, so general data type supported by your C language is only 4: int, float, double, char. So these are the basic data types supported by your C language. So if you want to say your data, the data which you are reading is an integer, so the control string that we need to use is %d. Suppose if you want to say the data which you are reading is a real number, we need to use f. So double and float are both are used to read the real number, whereas a float you can read it to a smaller range. Whereas if you want to read a bigger numbers, then we go for a double. Both are used to represent real numbers only. Real numbers only. So double is nothing but a long float. So float means %f, double means long float. Long means L, float means F, LF. %LF we use as a control string. To read a character, we use %C. Even string is nothing but string is not a data type. In C language, string is not a data type, but even then you can read the string using %S. Okay, in further discussions, we will have a detailed explanation of this. Okay, so this control string represents what type of data your variable is carrying. So for this particular example, what are the values that I need to read? Length and breadth. So how I need to write this statement? Let us think that my length and breadth are decimal values, like integers. So in that case, how I need to write that statement is %d, quotation close, comma, and L. So L is the name of my variable, and it contains decimal integer. Same way, the same statement again you write it to read the B value. Instead of L, you write breadth. Or you can read it in a single statement also, like this. Okay, in a single state, multiple values you can read in a single statement. Ensure that your variables are separated by comma and your control string is separated by either at least one space or no space. Okay, only one space or no space, no space inside. So this we'll discuss it in the next classes also. Okay, so scanf is the statement which we use to read the input from the input in the C language. So for processing, you can use operators like, for example, here we use a multiplication operation. Star is a multiplication; it will do the multiplication. And to display the output also, we use the similar syntax only, but instead of scanf, we use printf. Printf, again, same syntax, control string, comma, quotation. Your control string always, it must be in quotations. So control string, comma, variable name. So here you won't have ampersand. So the main differences I will tell you. Don't mind the spellings. Variable name. Okay. So the main differences I will tell you. One difference is here we use the keyword scanf. Here we use this keyword printf. All are smaller case letters only. And then here we use ampersand symbol. Here we won't use ampersand symbol. That is another difference. Another difference is while mentioning the control string, you should not use any predefined messages here. Whereas while displaying the output, your control string can be combined with some messages. Something like, suppose, for example, I want to find out the area. So finally, while displaying on my screen, I want to display like this: area equal to, here I want the value of the area. Okay, here I want to display the value of the area. So this message followed by the value of the variable. So wherever you want the value of the variable, there we need to provide the control string. The messages inside these quotations will be displayed as it is on your screen. Okay, so to write something on your monitor, you have to use printf. Okay, to read something from the keyboard, we need to use scanf. Yes.
What is the meaning of that percentage 2 times?
First percentage D is the L value. Second
Okay.
percentage D is the control string for B value. How many variables you are reading? You need to provide a separate control string for each variable. Say
Yeah,
L.
ma'am. And, yes. And I see at the one YouTuber show that we had to mention also the formula in scanf function.
No. Yeah, you should not mention the formula. You have to write a control statement like here. C equal to A plus B. Here you need to write.
Okay.
The formula. Okay. Or sorry, area equal to L plus L into B. A equal to L into B. Here you have to, this is called a processing statement. This is a processing statement. Whereas scanf is a input reading. From the keyboard, you are reading what is the value of L. You are asking the user to enter the value of L. Whatever the user enter, that it will store it in L. Whatever the user enter next value, that it will store it in B. Yeah.
And
Okay,
it will multiply and give us an output.
Yeah, it will multiply those two and store that result in A. That A value you are displaying here.
Okay.
Okay, this is the steps. Say Okay, I'm removing these statements. So first,
I'm asking
this
the
is,
question.
it will read the input. Read the input. This is the step. For processing, this is the step we have used. For displaying the output, this is the step we have used. Okay, so every program will contain these steps. Whereas, along with these steps, what we'll have is, first, you as a user, we are having assumptions that A is the area, L is the length, B is the breadth, but computer cannot do that assumption. So we need to tell the computer what type of data it is carrying, that variable. So for that we need a declarations. So first, whatever variables that you have used in the program, they are to be declared using your data type. So here, what type of data your L and B and A are carrying? They are carrying the integer data. So the integer data is represented in C language using a keyword int. Okay. So here we need to mention that A is an integer, L is an integer, B is also an integer. So all the A, L, B are integers. First, we need to tell that computer that thing. Then only it can assume that whatever the data that you are reading is an integer using this controls. So first we need to have a declaration. After that only you need to write reading the input. In this order only you need to follow. First you cannot interchange these statements. You cannot write this statement first. After that this you cannot. So first if you know the L and B value only, then only you can able to calculate the area. Okay. So if you calculate the area, then only you will have the A value. After getting the A value only, you can display it on the monitor. So this is the order. First, we need to read the input. After that, we need to write the processing statement. After that only, we need to display the output. This order you need to follow. So before all these three things, first we need to declare all the variables that we have used here. Okay. And C is a structured programming language, and it will contain so many functions. For performing each and every task, it will use one function. So among those, main is one of the compulsory function from which your program execution will begin and end. Always your program execution will start and end with the main function. Okay. So you have to put all this code inside the main function. You have to put all this code, whatever code that you are writing. Now, for a simple code, so that you need to put it inside the main function. So main function, this is a keyword main. Function means you will have, it will take some input and it will return some output. Input we need to provide, input variables we need to provide inside this brackets. Output you need to provide before the definition of this function. So you will encounter all these things later. So always we think that last statement that we write in any programming is return 0. So what is the meaning of this is, if your program, while executing the program, we may encounter so many errors, so many problems. So if your code reaches to the till the end, that means your program is executed successfully. To say that your program is executed successfully without any interrupt, this code will help you. 0 means your program is terminated successfully. If you have any non-zero value here, if you have any non-zero value here, that indicate the error code. Maybe this program may be failed because of so many things. Say, for example, I have mentioned length as L here, but here I have written my variable name as LEN. So it doesn't know what is LEN. It can only know what is L because you have written the declaration as L. Okay. So in that case, it will gives rise an error and then stop. Okay, so like that, or sometimes what I do, I may forgot to write this semicolon. So this is the syntax. Every statement must end with a semicolon in C language. So if I forgot this, another type of error will come. Okay, so each error will have some non-zero code. Say suppose if I forgot semicolon, the code might be 10. If I not exactly 10, I am saying, for example. So for wrong variable name, it might be 20. So like that, it will return when it encounters some problem. So it will generate that code and return. So this function will return some integer value. If that integer value is 0, that means your program is executed successfully. If it is returning some non-zero value, that indicate that your program is terminated with some errors. In that way, your CPU will understand. Okay, so this is the main function. So here we have written a functions like the scanf, printf. Those are not written by us. Those are called predefined functions. Predefined functions. So who will give you the compiler, C programming software? They will provide you some libraries in the form of header files. Okay, so in those header files, the definitions of these predefined functions are defined. So that header file we need to include to your program before executing writing your program. First, you need to include the necessary libraries that are required to run this program. So every program will have a input output functions in general. So we need to include #include stdio.h. stdio.h means standard input output header file. This is called standard input output header file, where you will have the definitions of all your input and output functions like scanf and printf. So scanf, printf functions definitions are provided in this header file. So this is a predefined functions. So to run your program, it requires that definition. So first we need to include that corresponding header file and then start writing the program. Okay. So this statement is compulsory in every C programming language, because every program will have either input or output. Definitely. So that's why this statement is compulsory. Whereas suppose inside the program, if you want to find out the square root of some number, suppose if I say find the square root of a, okay, so how I'll do is some sq is a variable, sq equal to sqrt of a. Sqrt is a function. Sqrt is a function in C language. It is a mathematical function. So the definition of that mathematical function is defined in a header file called math.h. #include math.h. Like that, or suppose if I use some string functions, like I want to know what is the length of my name. Name is a string variable. So how many characters are there in that name? Suppose you want to find out. So for that, we may use a function called strlen. We may strlen, string length. If you want to, suppose s is a string, you want to find out the length of the string. So strlen is a string function. So it is defined in a header file called string.h. So like that, your C language will provide so many libraries that we have seen it in the features. Okay, so these are those libraries, string.h. So then it will able to execute this function. If you include math.h only, it will execute this function. It will be able to execute this function. If you include stdio.h only, it can able to execute scanf and printf. So like that, If you are using a predefined libraries, then you need to include the corresponding header file in your program. If you are not using square root of a, then no need of including math.h. If you are not using any string function in your program, there is no need of including string.h. But including this is a must, because every program will have input output. For reading input, we use scanf. For displaying output, we use printf. Okay. So this is a simple structure of a C program. Okay. With this concept, now you look at into this program. So the first statement that we need to write is hash include stdio.h. So standard input output header file it is. And this is the main function. So main function definition is starting here and ending here. To indicate the beginning and ending of a particular block or a function, we use these curly brackets. Beginning, here it is beginning the definition of this main function. Here this ending of the main function. So whatever statements that you are writing must be written between this open and closed parentheses. Okay, curly brackets. So what I am doing here, I want to display a message hello world in my monitor. I want to display a message hello world in my monitor. So simply printf. Suppose you want to display something on your monitor, which statement we need to use? Printf. Which function we need to use? Printf function. Printf. And a predefined message you want to display on the screen, that is to be put it in the quotes. That is to be put it in the quotes. So whatever you have written in these quotes, it will be displayed as it is. As it is. And this is called escape sequence. The meaning of this is every escape sequence will have a preceded by this backward slash. So n indicate a new line. So after printing this, you go to the next line to say that we use this escape sequence. And every program will end with a return 0, because if you come to this statement, that indicate that you have completed successfully. Okay. So now we will see how to execute this. We will type it that in an editor. First you type the program in an editor, save it with some name. Okay. And then we have to compile this and then run it. So I'm using the online compiler to do the C programming. Online GDB compiler for C program. If you type this, so it will show you the path. Online C compiler, online editor. So this is the environment. And here you can choose your language, C language. Okay. Here, so already hello world program is there. If you want, you can remove this and then type it, no problem. Basic syntax, they will give you. Okay. So what is the first statement that we need to write? Hash include stdio.h. Okay. See here. Yeah. Let me write the code and then explain. Int main printf hello world. Within the quotation, I am writing hello world. Return 0. Okay, so this is the code, complete program we have written. So there is no input for this program, only output. Output is this hello world. So once we write this program, in general, if it is our own editor, we write it in an editor that you store with this program, we'll store it with one name. Okay, after that, we go to the edit IDE where you can run your program. So there will be options like compiling, running, like that. Okay. So here, because this is an online editor, So we'll have only run option only. So when you run this, you can see the output. So this is the output screen. So you can see the output as hello world. Okay. This is the monitor where your output is displayed.
Ma'am, can you show that code you written on that notepad from math.h?
This program you want me to show?
Yes, ma'am.
Yeah.
You write one program to get the letters or alphabets in your name.
Yeah. Say for example, I want to say hello and my name. It should display my name. So first it should read the what is the name of the user and say hello, that username it need to display. So to display the name, name is a string. So that means a set of characters, not a single character. So let S is the name or N is the name, think that. So N is the name. So name is not a single character. It will have multiple characters. I am displaying the maximum length of the string I am declaring here. So N of 20 means name will contain a maximum of 20 characters. Minimum you can have only 1 character, 2 characters or 5 characters or 10 characters, whatever it may be. You cannot store more than 20 characters. The length which we are specifying in the declaration is the maximum length. Okay. So N is a string. So string is to be declared like this in C language. Okay. So set of characters, group of characters. How many characters are there in this string? 20.
20.
Yeah. So N is a variable, string variable. So first you display on the screen. Enter. First, let me without display. I will show you the output. After that, I'll. SC. First, you need to read your name, because the input to this program is your name and output is hello your name. Okay. So how to read the string? I said %yes to read the string. And while reading the string, you should not use ampersand symbol. Why? That we'll explain it in the later cases. For all the other variables, we need to put an ampersand symbol here, scanning. But string we won't use, because string is not a normal data type, basic data type. Only for basic data types you will have ampersand symbol here. So because string is not a basic data type, we won't use it. So this is how to read your string. Okay. Now what I want to do, hello. After that, I need to display my name here. I cannot write name. So where is my name? Where is my name? It is there in this variable N. My name is stored in this variable N. So that N value I need to display. Okay, that N value I need to display. So hello. After that, here the N value, whatever the N value I gave from the keyboard, that value it is to be displayed here. So variable name, N is a variable. In this variable name you want to display here. So variable, wherever you need to display your variable name, there you give your control string. Okay. So now if I run this program, see here, this is output screen. Your cursor is waiting here. Your cursor is waiting here. For what purpose it is waiting? To enter your name. Okay. Yes. Say for example, I have written my name, Hemalata. So press enter. See here. So it has readed this value, and that value it has stored in N. After that, printf hello means hello. After that, here wherever control string is there, it will display the value of this variable. What is the value of this variable? Hemalata. So hello Hemalata. So if you run it next time, suppose if you provide Suraj, then it will display hello Suraj. So like that, we are reading the name. Okay, we are reading the name and displaying it with the hello. We are
Hello.
greeting it. Okay, so suppose I want to read one number. I want to find out the square root of it. Okay, say n1 is my number. So I want to read my number. Number means integer. Integer number means, suppose I don't have this. Let me remove this. So, but see, another difference I want to show. Wait. Before going to the, see here, what happened when you run, your cursor is waiting. Say you are in a software company, you are writing a code to solve some particular problem. So today you are working with some XYZ company. So you have written the code to solve some problem. After that, you got a good offer and you shifted to some ABC company. So in your place, this XYZ company will replace somebody else. So that person has to continue your work. So whatever the code that you have written must be executed by that person. So if your cursor is waiting here, you don't know what you have written inside this program. So he has double clicked on some task to execute your program. So your cursor is waiting like this. So will he know what he need to enter? He doesn't know
ma'am.
about this code. Just he has executing the program. Your cursor is waiting like this. So what input he need to give? Will he be able to know? No. So for that purpose, what we need to do is, always when you are writing a scanf statement, before that you write a printf statement
Printf
indicating the what you need to input.
Yes.
Always put a printf statement before the scanf statement. In that printf statement, you have to put a message what input it is expecting. Okay, so here we need to write enter your name. Here we need to write enter your name. How you, in which format you want, you write that. Okay, so capital letter, small letter, nothing matter inside quotes. Okay, you can write small letters, capital letter, whatever you have written, that is displayed on the monitor. Okay, so here you put, now when you run it, enter your name and then cursor is waiting so that he can know what he need to enter. Okay, Hema, enter.
Yes,
So
ma'am.
hello, I told this one. So that's why always it is a good practice to even the program will run without that printf statement. It is not compulsory, but a good practice. As a programmer, you need to follow that constraint, that what input you are reading, it should be known to the any user who is executing that program. Okay, for that purpose, every scanf statement will be preceded by printf. That printf will indicate only the message for what purpose you have written this scanf statement. Okay. Like suppose now what I want to do is, I want to read one number, integer value. So enter any integer, any number, whatever it may be. Okay. So for reading the integer, control string is %d, and this is a basic data type. You need to follow the syntax and n. Now what I want to do is, I want to find out the square root of this. I want to find out the square root of this. So sqrt is a predefined function which will find the square root of the given number. So I am storing that result in s. So in general, s will be a float, because suppose if it is a 9, n value is 9, the s value will be 3. Suppose n value is 5. That means square root will be something like a 2 point something. Decimal value you'll get, fractional value you'll get. So always your s is a float. Okay. Your s is a float. So how to display the float value? How to display the float value? Using percentage f. So how it should display is, it should display like this. Square root of, this is a message, square root of, inside this first value is n. So this first value will be displayed at first control string. So first control string is percentage d. So this n value. So square root of, suppose if I gave n value as 9, square root of, here it will display 9 equal to, here it will display 3. That square root value, it is stored in s. That s value it will display here. Okay. So if I run this, will it run? If I run this program, will it run? No. Why? It doesn't know what is square root. So that's why it gave the error. So if we want to make it to know the that function, what we need to do?
We need to include the
Math.h, because the definition of sqrt is defined in math.h. So we need to include that. Include math.h.
Ma'am, you said that square root is in float value, no, ma'am. What happens if you denote int s instead of float s, ma'am?
So it will truncate. It will truncate.
Okay.
Okay. See here, 2 point something something it gave. Suppose if I gave this also as an integer, but I will try to give you another. See here, 9. It will give 2 only. It won't give 2 point something. It will truncate the value. Okay. Your output is truncated to an integer because you declared your s as an integer. Okay. So anyhow, you'll encounter all these things later. Just to show you the syntax of how your C programming is, I have discussed all these things. Okay. So this is the simple C program structure. Okay. So what are the advantage of using the C language? Portability is having efficiency, that means correct without errors, making any errors, it will execute the program. Compatibility, so other languages like C++ and Java, they were extended from C language. Okay, it's like that. So with whatever I have discussed now, with that we'll fill the remaining bits quickly. So which of the following is true for C programming language? The features only they have asked. It is an imperative language, statistically typed, strong, structured programming language. It doesn't demand high capacity of hardware. Okay. Then suppose CPU supports only addition and subtraction, arithmetic operators. So you want to multiply those two values. So what we need to do? See here. Initially R1, how will you perform the multiplication? How will you perform the multiplication with the addition and subtraction? Suppose you want to find out 3 into 4. 3 into 4. So how you can able to perform this? Add
Ma'am, I repeated
4.
addition.
Add 4 3 times. Okay. So
Yes.
you're adding the 4 3 times. Suppose you want to find out 5 into 4. So add 4 5 times, like that.
5 times.
One is used as a counter, other one is used as a addition, repeated addition. So with that concept only, because here it is supporting only addition and subtraction, you want to multiply these two values. Okay. So how it is performing? So the memory locations given are M0, M1, and registers given as R0, R1, R2, R3. 4 registers are available, 2 memory locations are available, and 3 memory locations are available. Your result, you need to store it here. So A value is in this memory location, B value is in this memory location, and these are the registers, and you store the result here. Okay. So how we are executing, you see. So initially R0 is stored with the 0. Now first value, A value, we are fetching from the memory and then storing in R1, and B value we are fetching for M1 and storing in R2. Okay. R3 also we have taken it as a 0. Now what we are doing? We are adding R2, this M1 value, B value we are adding to R3. So 0 plus first 4. Say for example, A is 3, B is 4. So first 4 we have added here. Okay. And then R0 equal to R0. So you are using R0 like a counter, increasing each time. When we add first time, it will add 1. When we add second time 4, it will increment it to 2. When you add the third 4, it will be incremented to 3. Like that, how long it will be incremented till it reaches this A value. So this counter R1 value. Okay. So R0 equal to R1. So when we need to, what step we need to write here, so that this program will store the result in R3, like multiplication of AB in R3. That is the question. So what result we need to, what statement we need to write here? If R0 less than R1, go to step 5. So we are not going to, first step is step 3. We are not going to reassign. So with this, only this particular step is to be repeated. So definitely you can cancel step 3. So among these two options will be the right one. So if R0 less than R1 or R0 less than R2. So
MS R0 less than R1.
yes, because R1 we are used as a counter. So your R0, if R0 value is less than R1, you need to repeat this particular step. So this is correct. So manually you form the steps. That steps you write it like this. The how to write these steps I have already explained in the editor in the beginning. Okay.
So like in these steps, we are loading the value into register from the memory.
This is loading.
This is
the load instruction. From memory, you are transferring to the register.
So this process is called as a split memory architecture.
Yeah, this is called a split memory architecture.
Okay.
So identify the appropriate instruction to fill the blank. So this is the blank that you need to fill. Next, suppose two devices, monitor and keyboard, are mapped to the memory location 51 and 67. So that means monitor is mapped to 57. Keyboard is nothing but 67. Then its memory location is 67. We have to write a program which takes an input value from the keyboard and display it to the monitor. Identify the correct step. Okay. So what we need to write, when we need to do, we need to write a program which takes the input value from the keyboard. First, it need to read the value from the keyboard. After that, display that value on the same value, whatever it has read, that it is display on the monitor. So that means which of this? So first you read the first option. Read the value of memory location 67 into CPU register R. So in 67, what we have? Keyboard. Okay, in 67, what we have? Keyboard. So you are reading from memory 60. So from the keyboard we read, to the monitor we display. Okay, so this is correct only. So you are reading the value from the memory location 67, and that you are storing into one of the internal registers of CPU. After that, second step is write the value of the register R to the memory location 51. What is there in the 51? Monitor. So this is the correct step only. You are reading from the keyboard, and that readed value you are storing into the register. And whatever that is there in the register, you are writing that to the memory monitor. Okay, so this step is correct. Suppose if you see this,
Okay.
read the value of memory location 51. Is it 51 an input device? No. From where you will read? You will read from the input device. Input device is a keyboard. So you have to
Keyboard
read it
is 67.
67. So this is wrong. Next, write the value of R. First you are writing and then reading. This order is wrong. First you need to read, after the only you need to write. So this is wrong. Next, write the value of R. So again, this is also first writing step. So you can cancel these two. So the correct one is read the value of memory location 67 and write it to the register. And register value, next register value, you store it in the monitor. You write it to the monitor. Okay. I think with the basic that I have covered here, first you need to read the input and then process and then display the output. Because here in our problem statement, there is no processing step. Just you are reading and then displaying. So read from the input device first. After that, write that to the output device. So this step is correct. Next, a set of stored instructions used to direct your computer's central processing unit is called a program.
Program.
Which of the following components is responsible for managing a flow of data between CPU and other components?
Control unit.
Control unit. Which of the following component is responsible for temporarily storing the instructions and data during the program execution?
RAM.
RAM. So which of the following are examples of input devices in the computer architecture? Input devices.
Keyboard,
Webcam.
mouse,
Mouse,
Mic.
Mic.
Webcam.
Okay.
okay. Whereas printer is output device, speaker is an output
speaker is
device,
also output device.
even webcam.
Yeah,
But
input
they
device.
Yeah,
Now,
yes,
to
input
capture the
device.
view.
Yeah. Rank the following in the order of how much main memory RAM they had. Okay, so this you need to know about the recent scenarios. So you can search it in the YouTube. What is the memory, main memory of all these devices? IBM mainframe system, Apollo 11 guidance computer, Apple iPhone, Arduino Uno. So these are the IoT devices. So you search what is the memory occupied by these devices, main memory contained in these devices. So you put them in the highest order, which is having a highest, that option you select the first. next highest, next highest, next highest. Okay, so this is not related to the logic, just you need to know the competitive world, what are the main components and their memories. Okay, so I think this is the correct order. Arduino Uno will occupy more, and then Apple 11, and then IBM, and then iPhone. Okay. So, which of the following are computationally equivalent in theory? Note that two processors are considered computationally equivalent if anything that can be performed by one can also be done by the other, and vice versa. Like suppose you are performing a particular task using one device. If the same task can also be done by another device, then we say that those two devices are computationally equivalent. Okay, so all these three will be designed to do the same task almost. So all of the above are computationally equivalent. Okay, so these are like whatever the Apple M1 phone, MacBook can do, that can also be done by this one. The whatever this can do can also be done by this one. So all are computationally equivalent. Okay, so let us check the answers. So one answer is wrong. So we'll see which answer we kept wrong. Imperative programming language, statistically typed language, structured program, strongly typed language. It is not strongly typed language. Actually, say a description, it is given strongly typed language, but perfectly strongly typed means, what is the meaning of it is, suppose if you declare one variable a equal to 10, later if you able to convert that a into a string, in one place we used a as a integer, in another place if you use a as a string, in another place if you use a as a float in the same program, then we say that a value is dynamically changed from integer to float, float to string, like that. So then that is called a strongly typed language. But here in the initially, whatever you declare for a, declaration that we gave a, that value only it will accept. It won't accept any other value. If you declare your a as an integer, in throughout your program, your a can carry only integer value only. You cannot able to convert that into any other, like you cannot, it cannot carry any other value, any other data type. So we can't say that it is a fully strongly typed language. So that's why this option is wrong, because this in the material it is given that it is a strongly typed. That's why I have ticked it. But in the answer, they have omitted that. Okay. So those are the answers. Any other doubts? Anyhow, the basics which I have taught here now will be repeated from the week 3 onwards. Okay, you need not understand what is the structure of your C program completely now itself. Okay.
Okay, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Okay.
Thank you
Good
so
night.
much.